Hey buddy, so decorator design pattern. Okay, the first ask is there are so many design pattern in the market, in the programming world, then why this particular design pattern? Okay, so the answer is there are a couple of use cases where you can fit this design pattern. The first use case is legacy code. Okay, so legacy code means there is a code which was built from last 5 years and there is a possibly active development or no active development. But now there is a requirement that you have to add few more logic in the same method. Over there, making the change in that same class, what you can do, you can implement it this design pattern which is called decorator design pattern, and you can make sure you are not breaking the existing logic, right? Okay, now the other use case is whether you are part of that team which is just like 1 year old project or 6 month old project, but that code is already on the production. That code is stable. Maybe the code is little complex, but that code is stable. Over there you have been asked to add some more logic. Now if you remember the principle solid, there is a O, that means open for extension but close for modification, right? Over there you can follow that principle, that O, and you can make sure instead of modifying that existing logic, you are extending the part, right? Extending the additional functionality to it. So for those reasons you can fit this design pattern. Okay, now some people also call it wrapper design pattern, but decorated is more popular word, so you can make a sense when someone talk about either decorated or wrapper, so they're talking about the same thing, right? Okay, now let's jump into the code and let's talk more implementation part. So let's go ahead. Okay, so here we are in the Visual Studio, and if you look at this class, let's imagine either it's a legacy code, right, which was built from last 5 years, 10 years, any number, or a code which is already on the production, right? Okay, so if you look at this, I have one interface which have only two methods, right, description and cost, and we kept the logic very simple because our motive is to just understand the concept, not the business logic, right? Because business logic could be 100 lines, 50 lines, 10 lines, that doesn't actually matter to us. Okay, so this method says I'm returning cost, right? So I'm returning some random cost, and this method says that I can give you my car description, right? As you say, it says that this is luxury car, that's it. And now there is a program class which is making a call to those method right over here. Now requirement is, this was very basic thing, right? There's a requirement that they need to add some accessories to the car, right, to the description, right? As of now this car says that I'm just a luxury car, I don't have any accessories. Now you maybe wanted to add couple of accessories, let's say basic accessory, right? So normally what you will do, you will come here and add some logic over here, right? That you will say this is a luxury car plus it has basic accessories. Instead of that, remember solid principle, close for modifications, right? This class is completely closed for modification, but this class is still open for extension, right? That is what we have to fulfill. Okay, now how to implement that? Okay, so before we implement that, let's go ahead and let me show you one diagram. This is how actually we are going to implement the decorator design pattern. Okay, so if you see this part, let's focus over this part only, this part and this part, only these two parts, forgot about these two. Okay, so if you see, it says interface, which is component and concrete component. So two things, component and concrete component. So component is what? Interface, and it has operation. So if I can show you, this is component and it has two operations, right? Now concrete component is like a class, right? A simple class which you can create an object. So this class you can create an object, so it has those two operations, right? If you see operation, now this part is done here. Now that additional requirement, right? So that additional requirement, if you see here, it says we need now to implement decorator. You need that decorator class, right? That would be a component, and second would be your concrete decorator, which would have your operations, that is this part which is already there, and then additional operations you have to add. Okay, so this may confuse little, But even if it confuses you now, just forget about this. We will come back again once we implement, and that time it will be more clear and clear. Okay, now let's go to code. So if I can show you decorator, right? So it need one component which should be decorator, and it should have all the existing operations, right? It says existing operations here, and operations here. Okay, now let's see how to implement that. Okay, first thing what we will do, I will create one folder here, and you can say it decorator. It's all up to you how you want to implement, but this is the basic and standard way. Okay, so you can say this is decorator. Okay, now so I will create one class. So let's go there and add one class, and I will say this is base decorator, and since we are dealing with the car, so I would rename it to base car decorator, right? So let's say add. Okay, it is done. And now what we have to do, make it abstract class. So this is important, that you need a abstract class. You will get to know why we are saying that abstract class, not other class. Okay, so now we need the same operation, right, from the interface. So inherit that interface, implement that interface. Okay, and what was the interface was iCar service. Okay, let's go there, implement it, right? So I mean inherit it, and now implement. So let's implement. Come on, where are you? Let's implement. Okay, here you go, it is implemented right in the abstract class. Okay, now the further operation is you need a one constructor, right? So let's create one constructor and make sure that constructor is public constructor, because we are going to use it in concrete class, which is this class, this concrete decorator. Okay, so let's go there, and we have done here. Now what do we need? We need to pass this over here as well in that constructor, right? Parameterized constructor, and let's say car service. Okay, now for sure we have to pass in some, initialize that object. What we will do here, iCar service, and let's say this is underscore, right, because it is private, and I will say equal to, and you are here, right? So whatever object I will receive, I will assign that to it. Okay, now here you go. It was saying that what, add the same operation, right? Whatever operation was in interface in the concrete, add the same operation. Till here, this base decorator, there is no additional operation. Remember that, this is important. Till here, this decorator part, this is abstract class. This part, there is no additional operation. That means till this time, you are still trying to get the same implementation which was in the legacy code or which was already on the production, right? So what you will do, you will say, okay, let's say, return same thing, which is this one, right? This car service, which is from this interface, and get the codes. Same here, let's say return, and I will say here what, underscore car service, right? And what, say get description. So this way, let's say control by, and you are done. Okay, now this way you have fulfilled, you have a class ready, you have a base decorator class ready, which is going to give you the same implementation which is deployed on production or legacy code, right? Because you are not writing, you see, you're not writing any additional logic here. You are just making a call to the same interface, right? Okay, we are done here. Now let's go back to that diagram. Okay, now it says create concrete decorator. Now concrete is what? Normal class. Why we have not used a concrete word? Because this is abstract class, and you can't create object of abstract class. Something which you can create object, that is your concrete class. So it was normal concrete, it is here concrete decorator. Okay, now if you see here, this says operations plus additional operation. So that means it would be your that logic, right, which is stable, and then you will perform the additional logic. Now let me show you how you can implement that part. Okay, let's go there, and what we will do here, go to Solution Explorer, and we will create one more class. Let's go there, and so the requirement is what, let's say basic accessories, right? So I will say I need basic accessories, right, for car. Okay, and I would say for car, and I will postfix it with decorator, right? So make sure you are post fixing it will be decorator, and that would be the easiest way to find out for some other developers that this design pattern has been implemented and this class belongs to the decorator, right? I think I spelled wrong. Let's fix that. So it should be deco and it should be reader, right? Okay, so I'm adding one concrete decorator class. Okay, so we are done here, right? Now over here, if you look at the diagram back, if I can show you, come on. So you see now this concrete decorator is inheriting from that, that decorator, right, which is base decorator. So what we will do, let's go into the code and we will do the same thing. Okay, so let's say colon and inherit that base decorator that we had created. So it's very easy, right? Oh, you know what, we did one mistake, right? And that was what, because we have to override these two methods. So we have to create here virtual, right? So my bad, I forgot initially. So let's add virtual keyword over here, right? Because we are going to use polymorphism here to override this, right? See, polymorphism you are going to use, inheritance you are going to use, that that principle open close you are going to use, and all these will make decorator design pattern, right? Okay, now let's go there, and what do we have to do? Let's copy these two methods and here you go, right? So don't say this return, let's make this method empty for now. And what will we say? Instead of virtual, we will override that, right? So let's first override, and our two methods have at least an empty body ready. Now we will add some logic. Okay, but before that, I think we messed with spell, right? Yeah, we messed with spell, so let's fix it. So it should be decorator, right? So let's rename it everywhere, right? And let's rename it, come on, over here as well, and you are good, right? So at least my name is good now. Okay, so the next job is, we have to add, first of all, we have to call the existing logic, right, as mentioned in the diagram. First, this operation. Now divide concrete decorator into two parts. First, the same operation, the existing logic. Second would be additional operation, right? So let's first focus over this operation, right? How we can call the whole logic in the same method, in the same class. Okay, let's go to concrete decorator pack, and over here, what do you need? You need one constructor, right? This constructor, and what? And you know what? Let's do one thing. We need that interface, right? So what we have to do, we need this interface here as well. Okay, now this is base class, right? This is abstract class, and abstract class you can't create an object, and if you can't create an object, why you need a constructor, right? And if there is a constructor, you can't create an object, how you will make a call? For that you have a keyword called base, right? So we need to make a call to this constructor, this abstract class constructor, and we have to go through this. We have to say base, right? And then we will make a call to constructor here, and you will pass this interface object, whatever object it will receive, this class will receive, we will pass same to this. Okay, now what we need the same logic, the first part. For that, what I will do, I will say, hey, I need what? I need legacy code, right? And I will use, here you go. See, even Visual Studio is suggesting the same thing. And you go base.getCost, right? That is the same legacy code. Now, I need, let's just copy this, and I need this description as well. So what you can do, base.getDescription, right? So here you go. Now, the first part is done, right? This operation is done. Now we need to add some additional logic into this cost. Okay, let's say this is my basic accessory. So what I will do, I will say, okay, whatever the cost, whatever the logic is written, I don't know and I don't care. I have to add some additional logic, and I will say, let's say this is legacy code, that is fine, and I will add some response. Let's say I add increase by 2000, right? And then return the final logic, and you are good. So that means response from this legacy code, right? Let's say instead of code, let's say legacy cost even, right? So legacy cost, and whatever the legacy cost is, we are increasing it by 2000 because we are adding some basic accessory, right? This class is for basic accessories. Same for here. This is legacy code, and I will say instead of legacy code here, it's all up to you how you want to rename, but let's say this is my legacy description, right, coming from the old logic. Okay, now I will say, okay, whatever the legacy description, I want you to say that, you know, you have this also has been added, let's say added by some, come on, some basic accessories, right? So you can call it some basic accessories, right? I think messed up, so let's say copy from here and paste here. Okay, so basic accessories, right? So your method is ready. So what do we have to do? For sure you have to say return, right? So here you go, additional logic without making change in that code, still you are adding some of the logic. Okay, now what all we have to do, we have just implemented that, but we still have not called it, right? I told you that some people also call it wrapper design pattern. Now why they're calling it wrapper design pattern, now that thing will get clear. Okay, so now let's say this is my let's save it, let's go to program class, right? So this was the old logic, right, which was making a call to this. Now I need those basic accessories also. What I will do here, right? So whatever, you know, method which was calling, this is fine, right? So decorator design pattern says, you know, without modifying the object, add your own logic, right? Wrap your new object into the existing object and make a combination of old logic plus new logic, right? Don't change the current object, don't change the old object, right? So that is what decorator design pattern is. So I will show you what it actually means while writing the some couple of lines. Okay, what we all to do, let's, you know, comment this code for now, and you know what, we need to make a call to which was the class, this class, right, basic class. Okay, so now you will see what it actually mean when we say wrapper, right? Wrapper class or wrapping the object. Okay, so we will create an object first. Okay, come on, where are you? And say this is my object name and I wanted to create a object. Here you go. Okay, so now it needs one object in the constructor, right, which is that interface. Okay, no worries, we have that ready, which is this. Here you go, right? So I have passed, you see what I'm doing, I'm wrapping the object into other object, I'm wrapping the object into other object. Clear, right? That is what wrapping, that is what decorator design pattern, right? We are decorating the existing object into some additional object, right? Now what all I have to do, I have to start from here. Instead of that car service, right, what I need to do, I need to make a call this, and same here as well, right? I'm not modifying the existing logic, right? That existing logic, that existing object, we are just wrapping, and you are done. Now if I can show you here, let me run it, and you know what, let's do one thing. Let's say console dot write line, and maybe, you know, that will show us, give clear picture, and let's say get cost here, right, on the console print, and same for this as well, and you go. Okay, now I'm going to debug that, and then you will see the whole flow. Okay, so let's put a breakpoint here first, let's debug this, and now let's see the magic part. Okay, so F10, let's say F11, and go inside it. You see we are on the basic accessories class, right? So here you go, now we are going to that base abstractor, which is abstract class. You see base. So if I say F11, here you go, you are inside that abstract class, right, which is passing that object. Which object? Which is this object. It is saying that this is existing logic, car service, right? Car service class has the existing logic, pass into this class, which is, you know, concrete decorator. It came here, then it says, okay, I'm good, but pass that object to my that base class. Base class is what? This abstract class. Now you see it is right here, and it is initializing the object. It has passed the existing object. Now if I say F10, I'm good, let's go there, and now make a call to this get cost. Okay, if I say F11 here, you will see it reach out to this level, which is the concrete decorator. The first point is concrete decorator. Now once it reach out to here, you know, it has object of that, you know, car service, right? So it is saying base.get cost. Okay, go to there, we are here the abstract class. Okay, now if I say F11 here, you remember it will go to car service, right? So this is how it is working, right? That is how it will work, and you will get all the result. You will see we have added, and this is luxury car, plus we have added some additional text, right? That's some basic accessories, right? So let's close it. Okay, so now if there is an additional requirement that you need to add some logic for sports car, right? What you will do, you have this base decorator ready. You just have to go to your not this one, you have this base decorator ready, right? Which abstract class, you don't need to modify any logic. You just need one more class similar to this, right? You will create another class. Let's just copy this. You can create a different file also, but for our understanding purpose, I'm just copy pasting here the same thing, right? So what I will do, I will create a new class, I will inherit that, right? And I will just create a new class with the name, let's say sports, right? Sports accessories, right? And constructor for sure, let's paste it. And whatever details you wanted to modify, make a call to that legacy code, add some logic, right? Same for description, make a call to that legacy code, add some description, right? Let's say sports here, right? So this way you can implement decorator design pattern without making a code change to the stable code. Okay, so that's all for today's video. I will see you in the next video.